Let's look at F-statistics in more detail and see the mechanics behind the test. This is the formula for an F-statistic. The numerator consists of the sum of squares between groups divided by degrees of freedom between groups, and the denominator is the same but for variation within groups. There's a lot of jargon here, so let's go through each piece. Let's say you've been asked to evaluate the efficiency of 3 social service agencies, A, B, and C, in administering a particular program. The speed of delivering services is a particular concern, so you take a random sample of 10 cases in each agency and record the number of days required to process each case. We want to know if there's a significant difference in the number of days that the 3 agencies take to process these cases. Using ANOVA terminology, we want to test the null hypothesis that the mean number of days is equal for all 3 agencies. We'll test this by seeing if the variation between agencies outweighs the variation within agencies. If we test this hypothesis using the one-way command in Stata, we get an F-statistic of 20, which corresponds to a p-value of less than 0.0001. This lets us reject the null hypothesis and conclude that at least one agency's mean is different from another's. Notice that to calculate the p-value, we're relying on the fact that this test statistic has an F distribution. Now let's see where this F-statistic of 20 actually comes from. First, let's reshape the data from wide to long format so that each agency client pairing is its own observation. Using this new format, let's do a few calculations. Each agency has its own mean, so let's add a column corresponding to each observation's group mean. Next, we'll calculate deviation from group mean squared, which corresponds to the difference between each observation's time and the agency's mean time squared. So, the first observation's deviation from group mean will be 5 minus 7 squared, the second will be 7 minus 7 squared, the third will be 8 minus 7 squared, and so on. If we take the simple average of all observations across all 3 agencies without worrying about which observation corresponds to which agency, we get what's called a grand mean. This corresponds to approximately 11.67, so let's add a column for the grand mean. Next, we'll make a similar calculation called deviation from the grand mean, which corresponds to the difference between each observation and the grand mean of the entire dataset squared. So, the first observation will be 5 minus 11.67 squared, the second will be 7 minus 11.67 squared, and so on. Finally, let's calculate the squared difference between these two calculations, the group mean minus the grand mean squared. Let's take a look at what we produced in relation to the F-test diagram that we saw earlier. If we add all the deviations from the group mean squared, we get a value of 234, which is the sum of squares within groups. This corresponds to the within group variation that we saw earlier. If we add all the deviations between the grand mean and the group mean squared, we get a value of 346.67, which is the sum of squares between groups. This corresponds to the between group variation that we saw earlier. Note that it can be shown mathematically that the sum of these two values equals the sum of squared deviations from the grand mean, which we call sum of squares total. Intuitively, this is because each observation's deviation from the grand mean represents the total amount of variation in the entire dataset. Now let's apply these values to the F-statistic formula. Remember that an F-statistic tests whether the amount of variation between groups outweighs the amount of variation within groups. So an F-statistic is just a ratio between these two, with the sum of squares within in the denominator, and the sum of squares between in the numerator. To account for the number of groups and number of observations in our dataset, each of these values is divided by its own degrees of freedom. The degrees of freedom between groups is equal to the number of groups minus 1, which in our case of 3 groups is 2. The degree of freedom within groups is equal to the number of observations minus the number of groups, which in our case is 30 observations minus 3 groups, or 27. Plugging in all these values gives us an F-statistic of 20, which is exactly what we were given in this data output. You will almost never need to calculate an F-statistic yourself, but understanding the mechanics underlying Stata's calculations will help you to interpret results.